All right, and the amount of water produced is equal to or is determined. I'm glad I got my mic ready just for that. By the amount of hydrogen produced. Okay? How come we can't just use the same logic and say, well, the amount of oxygen produced is equal to the amount of oxygen that might be here? Because it also has other oxygen. Okay? Because these will have CHs, CHOs, CHONs, CHO, something from family 7. They can be pretty complicated. But C and H, we're going to use that and then subtract out from something else. So here we go. For the easiest ones, you just follow these steps. You first convert the mass of carbon dioxide to moles of carbon. This is pretty simple. Like, write it down, and then I'll show you, like yesterday, it might have seemed intimidating at the very first, but by the end, you're like, oh, I can do this all day long. All right, so mass of CO2 to moles carbon, convert mass H2O to moles H, 3, divide by the smallest answer, 4, write the formula. 3 and 4 should sound really familiar because it's the exact same thing we did with percent concentration. In percents, we converted percents to grams and then to moles and then divided by the lowest answer. It's just a little bit different way to get what we're after.
So are we going to start doing like aqueous gas instead of
Did you say aqueous gas?
aqueous and gas?
Oh. Yeah, we will when we get back into balancing, which is tomorrow. All right. So here's your example. A 1.5 gram sample of hydrocarbon undergoes complete combustion to produce 4.40 grams of CO2 and 2.70 grams of H2O. What is the empirical formula of this compound? Doesn't this seem wrong, just right off the bat? How can something that's only 1.5 turn into 7.1? Okay, remember, oxygen came from somewhere else, right? It was CH whatever it is plus O2. All right, so here we go. The first wrote down was to do what? All right, we're going to convert CO2 to moles. So the mass of CO2 is 4.4 grams of CO2. You know, I might as well just use this line here instead. All right, we're going to use what we call the picket fence to do this concept at first, and then we'll teach you a lot faster way to do it. All right, I want to end with an answer over here that says moles of C. So here we go. In order to end up with moles C, I got to get rid of grams of CO2, correct? We did this yesterday. We didn't do it in a picket fence, but we did the same thing. How did we convert the gram to a mole?
6.0.
No, that would put it into atoms. We don't want that. Divide it by its molar mass. So we add up a C and 2 O's, and it's 44 grams per mole. Now, I'm going to put another vertical line right here. We're setting up our fence. All right? So I got rid of grams of CO2. But am I at moles of C yet? No, it's really easy. I put mole CO2 on the bottom. And if you had chemistry last year, this one will seem a little bit different, but it's fine. For every 1 mole of CO2, I have 1 mole of C. All I'm doing is breaking the subscripts up. You with me? So in CO2, I have 1 mole of the whole thing, and in the whole thing, I have 1 mole of C. Really not that hard. All right. So I take 4.4 and I divide it by 44. hard. 0.1, right? 0.1 moles of carbon. Where'd I lose you? It's 4.4. They're all fours.
Where'd you get 44? Oh, okay.
44 was a 12 plus a 32.
Where did the O2 go?
I don't care about the O2. I don't need it.
But isn't that number included in it?
I'm not solving for it. I don't need it at all. Okay, it is true that for every 1 mole of CO2, there's 2 moles of O, but that doesn't matter to me here. I just need to get 2 moles of C.
So why'd you have like the third step like on the top? Why does that matter?
Why does it matter?
When you just divide this.
Mathematically, this is completely meaningless. But let's do the next one and just see why it does matter. So the next part is hydrogen. What was the mass of hydrogen? 2.7 grams of H2O, right? I'm not even going to try and draw a straight line. You'll see for sure, Jesse, why this last part's important. All right, so how many grams are there in a water molecule? 18 per 1 mole of it. What unit do I have on the bottom? The unit that's on top is always the same unit as the bottom of the next thing. So I have mole of H2O on the bottom. So for every 1 mole of H2O, I have 2 moles of just plain H. Okay. So is this important this time mathematically? You better believe it is, okay? This mathematically didn't matter, but chemistry-wise, we had to have this steps so we get the right unit in our answer. Okay? And you always need to have the right unit in your answer. It will make your life work, and it will make your math correct. If you skip steps, you're going to be in trouble. All right, so here we go. 2.7, so 5.4 divided by 18, I don't know, 0.4. What is it? 0.3. All right. Now, one of those is a smaller number than the other two, or the other one, I mean. So this one's the smallest one, right? 0.1. 0.1. I get 1 and 3. So my formula then is CH3.
So then you take the lowest one again?
Uh-huh. Once you get it to moles, you're ready to go. Okay. A different way to get to what we want, but still the same one. Who's with me? I don't know that that went real well. You're not with me? Okay. We got one more. You'll be able to prove it to me. I'm waiting. What? Are we doing an equation? Nope, we're just figuring out that it's
So
CH3.
do we not even need the 1.5 grams?
We will in 2 problems from now.
So is that just saying, so we have this formula, but maybe the molecular? Is this kind of
Yep, they could, if it said, and they really would, because this doesn't exist. This would be the empirical formula of probably C2H6. Like, I'm sure it is. If they did that, then they'd have to say the molecular mass is actually 40 whatever. But they didn't, so we'd get away with CH3. Okay, next one is the C. And then after that, we will need the original mass because things get real. Now, remember I said we could do it a lot faster? If you can remember, for carbon, you just divide the number by 44. And for hydrogen, you just divide the number by 9. Because 2/8. Then you can save that time, but if I just lost you, then do it the long way. I'm a long way guy, personally. Anytime I skip a step, I've usually tripped on the next one. Wow, what? That just looks terrible, doesn't it? Looks exactly the same. That's a 7 both times, I promise. Okay, here we go. Goals. I got this. 0.1. That's a 7. There we go. All right, anyone have this answer for me? 0.845 divided by 44? Point oh what? All right, what do we have here? Are you kidding? That's a joke. So, CH something, right? That's it. Because these are going to both be 1s. Now, that doesn't exist. So this is clearly a what? Empirical formula. How do I know it doesn't exist? Because hydrogen, no, it's not that. It doesn't complete its octet. Carbon needs 4, so it would work if hydrogen could produce a quadruple bond, but a hydrogen can only bond once. So that leaves carbon naked. It would probably be some large ring, is usually when you have a 1-to-1 ratio. All right. Those aren't that bad, right? So let's make them worse, because I get paid to. What if more than just H and C?
Oh, crap.
Then quit. Okay, don't do that. It's just more mathy. All right, so if you remember way back here we go, it said O is determined by the difference after C and H have been determined. All right, so if you have CH and O, and you know H and you know C, then you subtract their mass from the original mass given, and whatever else is left over had to be the oxygen. Raise your hand if you got that right there. Okay? It's whatever's left over, but you got to be careful.
Does that mean you'll have like a 16 extra because it's the mass? There's 16 minutes oxygen?
No. Nope. What it means is the following. Let's do it. Okay, so we have these right here. It was convert mass of CO2 to moles. You already wrote this, don't write it again. Convert mass of H2O to moles of H. Divide by smallest answer. Write formula. Okay. Should we do some adjusting now? Let's put a little star here. Well, you don't have to do it. You can write it however you want. If O is present, in hydrocarbon. I'm just going to say starting substance. Then you have a couple more things. Okay, so if oxygen exists, you actually take your grams of CO2 and you have to convert them to grams of carbon. You have to take your grams of H2O, you have to convert them to grams of hydrogen. Then you need to take your initial mass, that's given to you in the problem. It always will be. Okay? So your initial mass minus the sum of your grams C plus your grams H. And that equals what? Grams of oxygen. Now, 20% of you like how I just make up percentages all the time? It's fun. You know, I have no idea. But more people than should are going to then take these answers and divide them by the lowest answer. And then they're going to end up with ridiculous subscripts like C47H92O15. And they're going to think they're golden. False. We cannot take these numbers and divide by the lowest one because these numbers are what? Grams. So after we get grams C and grams H and grams O, then we got to go back to moles C, moles H, and moles O. Okay? See how not as fun this is? Now, in this process right here, this might lose you, but as we do the example, you'll get it. As you go from grams CO2 to grams carbon, right in this little step right here, you already have moles. If you'll just write that number down, because you're going to have to use that to get the grams, and you'll have moles. Okay? It will stare you in your face in your calculator, because this is kind of what you're going to do. Just follow my logic here. You're going to divide by 44. We're okay with that? Then you're going to have the 1 and the 1. Are you okay with that? But then you were going to have 1 and 12 to get the grams. But to moles, you're going to divide by 12. So you're going to divide the thing by 12 that you just multiplied by 12. So why did I have to multiply it by 12? Starts with a G, ends with rams. Grams. I have to get it to grams to subtract from my mass. And I know that some of you are super lost right now, but I will find you right now. Here we go. Is that the same one we just barely did? Hold on. Okay. Oh yeah, because I forgot I did that. Okay, it is known to have carbon, hydrogen, and oxygen. So that's the dead giveaway that this one's a harder one, because it's not just C's and H's. It undergoes complete combustion to produce all of this stuff. Okay? Man, I hate late start days. So let's fly through this and confuse you. So I'm going to do a bunch of picket fences here. Actually, just 2. All right, here we go. So still, let's just start with my mass of CO2. So 0.3664 grams CO2. I'll scroll up a little for you. How do I get rid of grams of CO2? Divided by 44 grams of CO2. And that number is for every 1 mole of CO2, correct? Now remember, this time I'm solving for grams of carbon. So there's a little bit more. How do I get rid of mole of CO2? All right, divide by a mole of CO2. So for every 1 mole CO2, How many moles of C do I have? I have 1 mole of C. Because remember, these subscripts are telling you the mole ratios, just like the coefficients will tell you the mole ratios. All right, now I'm not quite at grams C, so what do I need on the bottom? For every 1 mole of C, it has, from the periodic table, 12 grams of C. Okay, so I take 0.366, watch the math. I take this number, times it by 1, waste of time, times it by 1, waste of time. So I just take this number and multiply it by 12, right? And then, I'll divide it by 44. Now, I'm going to teach you something that I did when I was when I was your age, to help me. I wrote whatever this number was, that part. So the picket fence to here is just that number divided by 44, right? What is that answer? What? That number is going to be used later, right? Okay. That is the moles of C, which I'll eventually divide by. Okay. What was the answer? Huh? 4.396? That's way too big. 0.099? 0.09 looks great to me. All right, now, the next one, I had 0.15 grams H2O. I have 18 grams H2O for every 1 mole H2O. For every 1 mole H2O, I have 2 moles of H. And for every 1 mole H, I have 1 gram of H. This is an 18 right here. Is that what you're saying? .18. 1 what?